Hello everyone, myself Ankur Patel, and today we are going to learn development of surfaces. So today in this first session of development of surfaces, we will discuss what are development of surfaces of the solid. Then after we will discuss application of development of surfaces, and then after we will discuss example of development of surfaces. Now let's see what are development of surfaces of the solid. So development of surface of the solid or object means the unfolding or unrolling of all surfaces of the solids or object on a plane surfaces. So now let us see the development of these surfaces of different solids. So first is cylinder. So if we unfold the surface of the cylinder, it will be a rectangle having length equal to pi d, which will be equal to the circumference of the base circle or top face circle, and width will be equal to the height of the cylinder. Now let us see the development of the prism. So that the development of each prism will be a rectangle which is divided into number of rectangles. So here each rectangle will represent the rectangular face of the prism. So if we have a pentagonal prism, as here we have taken, the number of rectangles will be 5. If we have hexagonal prism, the number of rectangle will be 6. If we have square prism, the number of rectangle will be 4. And the width of each rectangle will be equal to the length of its base edge, and height or length of each rectangle will be equal to the height of the prism. So the development of cylinder and prisms are known as the parallel development of the surface. Now let us see development of some other objects. So cone. So the development of the cone is a sector of a circle which have a radius equal to the length of the generator of the cone, and the sector will be up to angle theta, or the angle of the sector will be theta, which will be equal to capital R upon L into 360 degree, where R represents the radius of the base circle and L will be the length of the generator. Now let us see the development of this pyramid. So here we have taken the square pyramid, and in case of the cone and pyramid, the development will be radial. So the development of the square pyramid will be a number of triangles attached at the same point. So right now we have 4 triangles which have a length or side length equal to L and base length equal to S, where S is the base edge length of the square pyramid. So the development will be 4 triangles attached at the same point, and this development is known as the radial development. So if we have pentagonal pyramid, we will get 5 triangles. If we have hexagonal pyramid, we will get in the development 6 triangles. Now let us see the application of the development of surfaces of the solid. So development of surfaces of solids are used in sheet metal work, where we have to make the article from a sheet metal. So to make any article out of sheet metal, first of all we have to prepare its development, and then we have to cut the sheet metal according to the shape and size of the development, called the blank, and then roll it into the required shape of the articles. So articles like containers, cupboards, lampshades, radio and TV cover, car and ship body, packing containers, etc. are made of sheets, and hence in fabrication the knowledge of development of surfaces of the solid is necessary. Now let us see the problems of development of surfaces. So the first problem is a right regular pentagonal prism, edge of base 20 mm and height 50 mm, rests on its base on HP with one of its base edge perpendicular to VP, and AIP inclined to HP at 30 degree and perpendicular to VP cuts its axis at a distance of 30 mm from the base. Develop the lateral surface of the truncated cut prism. Now in this example, first of all we will draw the front view and top view of the pentagonal prism. So for that we will apply the given data. So right now it is given that it is resting on its base on the HP with one of its bases perpendicular to VP. So right now the base of the pentagonal prism is on HP. That means the base is parallel to HP and it is perpendicular to VP. That means we can also say that the axis of the pentagonal prism will be perpendicular to HP, parallel to VP. So the top view of the pentagonal prism will be a true shape of its base or the top face. So let us start with the top view of the regular pentagonal prism. So first of all, draw XY reference line, and we will use the first angle projection method. So the top view will be below the XY reference line and the top view will be the pentagon, and in the top view we have to take one of the bases perpendicular to the XY reference line, because it is given that one of the bases is perpendicular to VP. So we have to take one of the bases of the pentagon perpendicular to the XY reference line. So draw a pentagon having side length 20 mm, which will shows as the top face, or which will shows as the top view of its base and the top face. So this will be 1A, 2B, 3C, 4D and 5E. So A, B, C, D, E will be our top view of the base, and 1, 2, 3, 4, 5 will be the top view of the top face. Now first of all, mark the center to show the axis. So for that connect the midpoint of one of the bases to the opposite corner, and again take another edge, base edge, and connect it to the opposite corner like this. So we will take this base edge and the center of this base edge is connected to the opposite corner, and the intersection of this edge and this edge will be the center. So this will be the top view of the axis. Now we have to draw the front view. Now the top view will be the true shape of its base and the top face, and right now the axis of the prism will be parallel to the vertical plane. So the front view of the pentagonal prism will be a rectangle. So first of all, project all these points vertically upwards, point of the axis. So here we will get the front view of the base. So here we will get A dash, so this is B dash, E dash, this will be our O, and this will be our C dash, D dash. So first of all, draw the base. Now here the axis height is 50 mm. So from this point measure the axis height and draw the side edge, that is 1A, 2B, 3C, 4D, 5E are the side edge, and the length of the side edge will be equal to the height of the axis. So now draw the side edge having height equal to 50 mm. This will be A dash, 1 dash, here we will get 2 dash and 5 dash, and here we will get 3 dash and 4 dash. So this will be our top face. This will be 1 dash, 2 dash, 5 dash, this will be our 1 showing the axis, this will be our 3 dash, 4 dash, and this will be our top face. Now before showing the development of the section part, first of all we will show the basic development of the pentagonal prism. So for that, first of all, project this height and draw a line parallel to this line showing one of the edge. So we will unfolding the pentagonal prism from the side edge A1. Now measure length of 5 into the side length of the or basis length of the square prism, which will be equal to 5 into 20, which will be equal to 100. Now divide this line into 5 equal parts to show the another rectangular faces of the pentagonal prism. So this will be the basic development of the pentagonal prism, which will show the rectangular faces of the pentagonal prism, and pentagonal prism has 5 rectangular faces. The width of each rectangular face will be equal to the length of its base, and the length will be equal to the height of the pentagonal prism. So this point will be our A, B, C, D, E and A. This will be our 1, 2, 3, 4, 5 and 1. So this will be the front view, top view and the basic surface development of the pentagonal prism. Now we have to show the cutting plane, and we have to then after we have to show the development of the lateral surface of the truncated cut prism. So first of all, we have to take the cutting plane, and here the cutting plane is AIP, that is auxiliary inclined plane, inclined to HP at 30 degree and perpendicular to VP, and cuts its axis at the distance of 30 mm from the base. So first of all, measure this distance 30 mm from its base. So now draw the cutting plane line, inclined at an angle of 30 degree and passing from this point, which is the intersection point of the cutting plane and the axis. Now after showing the cutting plane, we have to remove the upper part of the prism. So the lower part will remain as it is. So we have to draw the outlines of the lower part by the dark outlines. So draw it dark. Now mark the intersection point of the cutting plane to the side edge of the prism. So mark this point 1, 2, 3. Now we have to project this intersection point in the part of the development. So first of all, project this point over here. So we will get the intersection over here, A1 and A1, because the cutting plane is intersecting the side edge A1. So we have to mark this point over here on the side edge A1, A1. Now project this point. So this will intersect at B2 and E5 side edge. So here we have two side edge, B2 and E5. So mark this point. Now project this point. So it will intersect over here and give the intersection over here on the side edge 3C and D4. So the cutting plane is intersecting over here. Again, here the intersection is on two side edge. So the side edge are 3C and 4D. So mark this point. So this will be P, Q, R, S, T, U. Again P, because here the side edge is same side edge that we have taken over here. Now mark this point over here. So here we will get P dash, here we will get Q dash, T dash, and here we will get R dash, S dash. Now connect this point PQ, QR, RS, ST and TP. Now here we have to show the development of the lateral surface of the truncated prism. So the upper part is going to be removed. So draw the dark outlines in the lower part from this section. So show the lower part by the dark outline. So this will be the development of our pentagonal prism. So this is it for today. Thank you for watching. See you in the next lecture. Till then, take care.